So we're going to compare and contrast two polynomial functions here. The first one is a quadratic whose factor is x minus 3, which means there's a 0 at positive 3, but it's raised to the second power. This exponent right here is known as the multiplicity of the 0. So it's a 0 of 3 with a multiplicity of 2. In this second function, we have the 0 at 3, but it's raised to a multiplicity of 3. So we can say the 0 has a multiplicity of 3. And we can see that both these graphs behave differently at the 0. The quadratic graph comes down and then bounces back up, whereas the cubic graph actually crosses through. And that is directly because of the multiplicity. So we can see this a little bit more closely if we do a quick table of values here. When I let x equal 1, the output I can see is going to be positive 4. When I let x equal 2, the output is 1. Here's my 0, and then at 4, it bounces back up again. And we can see that by the nature of the square. The square is what's going to cause all those values to remain positive. When I move over to the cube, however, I can see that when I put x equal 1, the output is going to be a negative 8. When I let x equal 2, the output is going to be a negative 1. There's my 0. And then as soon as I let it go, let x equal 4, the multiplicity of 3, or the power of 3, then brings these values to be positive. And 5, again, gives me a positive 8. So the multiplicity directly affects how the graph behaves at a 0. If it's an even multiplicity, it's going to bounce off of the 0 or just touch the 0. If it's an odd multiplicity, it's going to cross through.